Okay. Here I have a rectangle. How do I find its area? Length times width. L, oops, wait, you guys are taught. W, L. Agreed? Area equals length times width. Yeah? If I know the area and the length, can I find the width? Yes, how? Division, algebra, right? If I know the area and the width, can I find the length? Yes, algebra. Again, that's the biggest grape I've ever seen. It's like a plum. Is it good? Nice. So everybody understands length times width, yeah? Yeah? Okay. What if it's a square? Is a square still a rectangle? Yes, of course it is. So we could still do W and L, couldn't we? Except what about a square makes it special? Micah.
All sides are equal.
All the sides are the same. So we don't need 2 letters for L and W, do we? I can use just 1 letter, can't I? Can I use S for side? Great. So we know that area equals LW, but if L equals W, then I can say S, can't I? And area would equal S times S, which would be S squared. Yes? Now, everybody cool? Now, in this question, on a rectangle, if I wanted to find one of the sides, Hayden tells me I got to use division. I got to do algebra, don't I? Right? Because I do the opposite of what I see. Area equals length times width. So I do the opposite of that, which is division, right? Okay. In this one, I've got area equals S squared. What's the opposite of squared? Square root. So, to find the length of a side, I would take the square root of the area. Everybody cool? That, ladies and gentlemen, is why we call it squares and square roots. Because they come from the actual shape of a square. There's 4 in there, 2 by 2. Everybody good? Yeah? Okay. This symbol is asking you to find 2 equal factors. I'm just going to write as 2 equal factors. Everybody cool? All right. Now, let's look at this guy. Volume of a rectangle. Volume equals what? Length times width times height. W, L, H. Right? L, W, H. If I know 2 of them, I can find the third using what? Division again. It's algebra again, right? If I know 2 of these. What makes a cube special? Is it still WLH? Yes. Volume of a cube is still LWH, but what makes a cube a cube? All sides are the same. So L equals W equals H. So do I need 3 letters? What do I need? 1 letter, S. S times S times S would never be written. What would we write? S cubed. So the volume equals S cubed, correct? So again, if I'm given the volume and I need a side, what am I going to do? Well, when it was squared, I took a square root. So what do you think I'm going to do here? A cube root. I'm going to take a cubed root. Now, if a square root asked for 2 equal factors, what then must a cube root be asking me for? Asks you to find 3 equal factors. Now, in our math course this year, we have already used squared and cube roots, yes? This little 3, and I'm going to highlight small 3, is called the index. The index tells you the group of factors you seek. So, in a square root, we don't write a number there. Because we don't, what is the other number we almost never write? In math class, we almost never write 1, do we? We never write 1x or x to the 1, do we? But in square roots, I can't ever put a 1 there, can I? Because one factor, you can't have one factor. So in square roots, when there's no number there, it's supposed to be a 2, but we don't write it because math guys are lazy. That's the only time in your math career. Everybody cool? So in this case, I'm looking for 2 factors. What if I was looking, in that case, I need how many? What if that's the case? Four, 5, x. X amount of factors. Whatever number is there, that's the group of factors I need. Does everybody understand? Yeah? Sweet. All right. A perfect square or a perfect cube is any real number with a rational root. Now, most of them, like, you guys are cool with the regular easy ones, right? What's the square root of 4? 2. What's the square root of 25? 5, right? You're easy with those, yeah? Those are all perfect squares. For our purposes today, that's what I mean by perfect square. There are others, though, yes? For example, don't write this down. The square root of 2.25 happens to be 1.5. Is that a perfect square? Does it have a rational root? So is it a perfect square? Yeah. But for our purposes, we're going to talk about the really tidy ones. Just the natural square roots. Actually, the whole number square roots. Everybody cool? And we're going to do that on the next page. This is so useful that after multiplication, remember how often I've talked about memorizing your times tables? The next most important thing you can do to make math easier for yourself is memorize the next 30 things that we are going to write down. I know, right? Holy crap, you could play softball with that thing. You'd have to eat it like an apple. You couldn't put it all in your mouth at once, because what if someone surprised you? You would choke. But don't worry, I would Heimlich and save you. Although they don't call it the Heimlich maneuver anymore. Did you guys know that? It is not called the Heimlich maneuver anymore. I don't know why, but it's not. Nobody calls that. It's called abdominal thrusts. But that sounds naughty. So Heimlich maneuver. Did you know this? Dr. Heimlich was a real person. And he might even still be alive or very recently dead. He was in a nursing home in Ohio in the United States, and somebody beside him started to choke. And Dr. Heimlich himself administered his own maneuver to the person beside him and saved their life. True story. But they don't call it the Heimlich maneuver anymore. I don't know, man. Because I don't care that much. I have better things to care about in my life. Somebody told me that when I took my last first aid, I said the Heimlich maneuver, they said we don't call it that anymore. I said, okay. Because it doesn't matter why they don't call it that anymore. What matters is I know how to do it. So anyway, how did that... Oh, you're great. Back to here. After times tables, this is the most important thing you need in your brain about math. after times tables. So let's go. Perfect squares from 0 to 400. I like to put the squares on the top and the roots on the bottom because roots are underneath. What's the square root of 0? 0. Nicely done. 1 is the next square root. What's 1 squared? 1. 2 is the next perfect root. What's 2 squared? 4. Go up until you get to 400. I'm going to run out of room. I'm going to stop at 100. Now, let's pretend you don't know these. Right? You should notice a pattern. +1, +3, +5, +7, +9, +11, +13, +15, +17, +19. What's the next one? +21, which would be 121, which would be 11. What's the next one? It's going to be +21, yes? Right? Or 23, which is 144, 12. And so on. And I'm not lying. Knowing these is super important to making your math life easier. Then the cubes, same thing. Now you're going to write all those down. I'm going to let you write them down for a few seconds more, then I'm going to talk about them for a second. There's some patterns I want you guys to recognize. That's why I left this empty space here. Right? Does everybody have these written down or close enough? You can get them off. You can check them later. I just want to show you this while you're thinking about squares and square roots. The square root of 400 is 20. Agreed? Okay. What's the square root of 100? That's 10, yeah? What's the square root of 4? That's 2, right? What do you notice about 104 and 10 and 2 that works with 420? Isn't the square root of 400 the same thing as the square root of 4 times 100? What's the square root of 4? 2. What's the square root of 10? What's the square root of 100? 10. If it's 4 times 100, then it must be 2 times 10. Does everybody see that? So could we use this to go higher than 400 if I wanted to? It wouldn't be hard, would it? What would the square root of 900 be? Yeah, except you just use your calculator. What would the square root of 900 be? Well, wouldn't that be the square root of 9 times 100? What's the square root of 9? 3. What's the square root of 100? 10. So the square root of 900 must be 300, yeah? Or 30, right? Everyone agree? Yeah? Okay. So what then would the square root of... Try to do one in my head. Nah, I can't be bothered. That's enough. Everybody see how it works, though? They stack on top of each other, yeah? Okay. So now we are going to, without our calculators, we are going to do some estimation. Because I have proven to you numerous times that if you guys use estimation, then you will be able to know better if you have done the work correctly, rather than do a half a page of work and have it all wrong. So how are we going to estimate this number without a calculator? Well, we have a list, don't we? I want the square root of 72. Where does that fit in on my red numbers in the top here? It is between 8 and 9, isn't it? Okay, so the square root of 72 is between 64, which is 8, and 81, which is 9, yes? It makes sense that if the 72 is between 64 and 81, then the square root must be between 8 and 9, yeah? Okay, how far is that from 64 to 81? Pardon me? It's 17, isn't it? Right? How far is it then from 64 to 72? 8. So I took 8 steps out of how many? 17. So this square root is 8, because it's got to be at least 8, and then 8 steps out of 17, yes? Now that's a yucky fraction, but it's awfully close to what fraction? 8 out of 16, which is 8.5, yes? Which means a very good guess for the square root of 72 would be 8.5, wouldn't it? Square root 72. 8.48. Is 8.5 a good guess? Great, let's do the next one. What's 180 between? It's between 13 and 14, yeah? 169 and 196, right? So it must be 13. How far is that? 31, right? 31. 27. 27. And how far did I go? 11 out of 27. Pretty close to 10 out of 30, isn't it? Pretty close to 13 and 10/30ths, which is pretty close to 13.3, yeah? $13.4. Everybody see how to do it? Do you think it changes if I get down to these, which are cube roots? No, what are you going to use instead? The cube root list. 300 is what? Between what and what? 17 and 18, which is 289, 324. Now, I don't want to round this I don't want to do this subtraction. I'm trying to estimate. I want to be quick. So what can I change that to? 290. What could I change that to? 325. Now it's a 35-step gap, yeah? How far am I past 300? 10. 10 out of 35, right? Little less than a third, yeah? Well, if a third's 0.3, I want to go a little less than that, don't I? So what about 17.2? Let's check. Root 300. Whew, 17.3. Everybody good? So here's what you are going to do. First of all, you're going to try those three. Then you're going to do a bit of weird work. Okay, so don't bother trying those three yet. On this page, page 93, I don't want you to use your calculator. Okay? I want you to ignore these instructions. On page 93, I want you to estimate the root. Doing what we just did up there. Okay? Use your brain. You're smart kids. Everybody good? On page 94, you can go ahead and use your calculator because there's some patterns I want you to see on that page. All right? So on 94, here's what I want. You can use your calculator. Okay? How do you know if something's irrational when you're using your calculator? Screen fills up with no repeats. So on this page, you're actually going to follow these instructions. You're going to use your calculator, and if it's irrational, you're going to tell me if it's irrational. Everything okay? Because when you're done this page, I'm going to use that to show you some stuff about doing square roots and cube roots in the future. Because pretty soon, you're not going to touch your calculator to do these. Because you're not going to have any irrational answers. Everybody cool? That's step 2. So that's not a lot of work today, right? It's doing what we just did in our notes, and then it's all calculator. Then, remember how I said I wanted you to save this side of this page? And when you look at it, it's half a page, but when you look at it, it really isn't. Right? It's 1, 2, 3, 4, 5, 6 questions. This one is crazy hard. The answers are on the page, but if you can explain that to me tomorrow, 10 gummies. Number 15. That's back on page 90. So, once again, 93, you're doing exactly what we just did. 94, you're using your calculator. And 90, you're just doing the right side of the page. And you got half an hour to work right now. Quickly, I'll show you these, though. That's between 27 and 64, right? Right? 3 and 4. This is how far. 18. This is how far. 37. Right? What's that pretty close to? 3.5. Because 18 out of 36. Everybody good? It's the exact same thing except we're using the cube root list. And trust me, there's a reason for making you do this estimation. Okay? Do those 3. Start your work. Yes, you can. Please notice that after lesson 3.6, we have our next quiz. Okay? This we are doing page 93 to 94, and the right side empty. You're going to have a quiz. Today is Tuesday. You're going to have a quiz. Thursday. Everybody good? Okay. I'm going to pee. Got these pants for $5 in Ecuador. They're not worth $5. But they're nice and warm. I'll be back. David, you're in charge.
I'm in charge.
Teachers had to wear like, what did those girls teachers have to wear back in the day of elementary school? They had to wear that thing that like every white girl wears now. What's that called? It's like that, I don't know, it's like that thin wool jacket.
Cardigan.
Cardigan, that's it. They had to wear that. And they had, if they were, I don't have to wear a dress. Pretty whack.
All my teachers wore that. I don't know why. I know, like, I didn't really need to. I was looking for my pants this morning. I couldn't find them, so I just thought these on already. So, like,
I already did like. That was a fast beat.
I don't know what you guys do in there.
that was really fast. Like, sometimes.
I strolled. To be fair, you don't have to walk as far in the staff bathroom to get to the pee places that you guys have to. Right? Because when you go in the pee place at the far corner, isn't it? Aren't it stalls first?
Yeah.
Yeah.
Like, and if there's someone on like the left side and the right side, there's no way I'm going in the middle.
No way, you can't.
What do you do at the P&E when it's just a wall?
I don't think I ever.
When you go to Playland and pee, you're just peeing on a wall. There's no stalls, there's no urinals, nothing. What do? Just stand there and wait?
I don't think I ever.
Yeah,
peed at the
you full send. You just full send. But you have to have it, like, it's bigger than this desk space. If Jacob is here, I'm not peeing here. I'll pee here.
You guys are crazy.
There's a rule.
If a guy starts peeing
What do
in the
you
middle
do at the
stall,
swimming pool?
Pee in the pool. No joke.
Like in the pool with the shower. You guys go to the family showers, don't you? So you get your own little stall.
No, I don't shower.
You don't shower when you get out of a pool?
I shower at home.
Yeah, why would you not shower at home?
All the people that shower are probably like old guys. It's like weird.
And they're all naked. They don't care.
Just walk around
I
there.
know. It's a dressing room.
No, if a guy sits beside, like, okay, if I'm here and this stall, if this urinal is open, and I pee here, Jacob's already peeing here,